Hi everyone, thank you for coming and thank you for watching. I'm gonna present what I did the last week. So I'm working on a project called Autoscan AI. It's for early prediction of brain tumor. What I did this week is improve the model uncertainty and trustworthiness. I tracked the training more systematically using TensorBoard, and I explored deployment formats like ONXX, and I did more research about explainability for medical users. Okay, just a second. For calibration matters, I discovered that in medical AI, accuracy is not enough. Even if I have 99% prediction, it doesn't mean that it's actually certain, which is why I added calibration measurement. The confidence scores reflect actual correctness, and the system is safe and stable under noise. For this, I use temperature scaling and something called ECE, which is expected confidence error. The temperature scaling adjusts the model's probability so confidence matches real accuracy without retraining. It's something we use after training the models that adjusts the softmax and brings the confidence and accuracy to real expectations. With the learned temperature that I did, it was around 0.90, which is very close to 1. It meant that the model was a bit overconfident, and for this I did like a before and after to see what changed exactly. And the results for the ECE improvement was like the best seen in the noisy MRI, where it like went from 0.001 to 0.087. And after that, I did the training tracking improvement with TensorBoard. It lets me see the model like is learning the accuracy and training patterns, loss curves, learning rate, schedule, confusion matrices, augmentation performances, everything that can help me improve and like track mistakes, track anything that I need to change or if it was like overconfident. And for the results, the accuracy improved and the confusion matrix is nearly diagonal now. This is the confusion matrix and some like for accuracy training patterns. Also, I try to do ONNX expert.
Can you go back and explain the table?
Oh yeah.
The matrix?
This one? The matrix, you can have like for every one, like which one was truly predicted correctly. For like glioma, it's like 640, but there was like 8 errors in meningioma and like 6 for non-tumor. For non-tumor, it was mainly non-tumor, but also sometimes like glioma and meningioma. And for this, like, it was worse before, and now it's like more diagonal. I just have like some small errors in between that I need to correct, and mainly the ones that are like something and that shows no tumor. I'm working on specifically trying to like not have any false like prediction about a tumor and having it like a no tumor. That's like the basically like my goal for now. And after that, I tried to do like an export attempt with ONNX, but I had many challenges and it failed so much that for now I decided to like stop it and then like maybe return to it or try with some other tool. Also, last time I said that for the motion, it was I had like some issues with motion pictures or like blurry. For that, I tried to do something. I added like an automated pipeline to handle unstable predictions. For this, I implemented a sharpness detection, like detector that knows what pictures are in motion or blurry. And for that, it takes those pictures and it brings it to a function that does like sharpness correctness. If the sharp edges are like below a certain level, it triggers like a threshold, and the system flags this picture as a motion degraded picture. and it brings it to like a correctness algorithm that does like normalization, unmasking, like more sharpness, and then the corrected version goes to the calibrated Maxwell or like the ensemble classifier, whichever has the best results. And for this, now like the motion affected pictures are no longer a big problem. Also, for the medical explanation module, which is also one of my goals, I tried to integrate a lightweight text generation model, which is the FLAN T5 base, to produce some technical explanation, tumor type, the confidence and uncertainty levels, and why it gives that. For now, it's like just small sentence of like, this is glioma because the confidence level was like this, which is not what like I'm looking for. So I did more research about it for like real medical LLMs on Hugging Face, like BioGPT or MedPal-M. For this, I need a bigger like server for like a higher GPU, and because I'm gonna download large files and data sets, which I couldn't do this week. So hopefully next week we'll do it with a server. Also, this is what I have for now as like early application. You just go and like put any picture that you have, and you have just the confidence calibrated now, which went down because of that. But now it's like more real, and it gives you also like if it was like a motion or blurry picture, it gives you a certain threshold, and like this picture was in motion, and then corrects it and like does the prediction. So yeah, this is what I did, and this is the, I can show, this is the Autoscan AI app for now. You just go and like take anything from any picture. For example, here the meningioma, I can just track anything, and it will give the confidence calibrated, also like the probabilities for each class. And this is like just for now with the simple LLM that I'm using, which again, it's not the goal. So yeah, hopefully for the next weeks I will have like a better generated AI that does like a thorough explanation for doctors, for everyone to just like really know what's happening in the picture and what type of cancer, and like a lot of like guidance through that. A heat map is like it detects where the actual tumor is, and it gives you like the red part is like where the main problem is, and then it's like not like the blue part is like the safe part. It's like a library that you get and like you implement with what pictures you want and like what you want to have. So like when the program detects like where it is like the issue and why it predicted that, then with the grad heat map thing, it like the thing that you detected like brings it like the colors to it to show like where is exactly this issue. But yeah.